short-term blood pressure regulation. The carotid sinus. It says have stretch receptors in their walls. Give afferent via glossopharyngeal nerve. Stimulate respiratory center. Contain chemoreceptor. Stimulate the vasomotor center. What is your normal blood pressure? If you perfectly healthy and normal, your blood pressure will be somewhere around 120 by 80. Blood pressure will be somewhere around 120 by 80 millimeter mercury. Now I am going to do an experiment. I am going to transfuse 2 liters of normal saline to you rapidly. What happened to your blood pressure? Definitely blood pressure will rise. 2 liters of normal saline rapidly. After about 1 hour, your blood pressure is 160 by 110 millimeter mercury. Then what happened? Your vascular system now under stress. Why? They have to accommodate large amount of fluid. They have to accommodate large amount of fluid. Previously 120 by 80. Stretch is less. Now vascular stretching is much more. That stretching is transmitted to aortic arch. Previously stretch was this much. Now aortic stretch is this much. Why? Pressure is high. Not only that. Previously carotid sinus stretch is this much. Now because of transfusion of 2 liters of normal saline, 2 liters of normal saline, now stretching is this much. What happened? Aortic arch and carotid sinus wall contain stretch receptors. When that wall is stretched, that receptor is going to be activated. That receptors contain sodium channel. Once those receptors stimulate, sodium channel open. Then what happened? Sodium rapidly go into the inside of the nerve membrane. Nerve become depolarized. Now this nerve become depolarized and this nerve also become depolarized. From aortic arch, that depolarized wave carried via vagus nerve. From carotid sinus, that depolarized wave carried via glossopharyngeal nerve. They carried impulse to the brain stem. Exact point is nucleus of tractus solitarius. Here, nucleus of tractus solitarius. If this nerve is stimulated, they going to secrete inhibitory neurotransmitters. If this nerve stimulate, glossopharyngeal and vagus stimulate, they going to secrete inhibitory neurotransmitters at the level of nucleus of tractus solitarius. Once this nucleus of tractus solitarius inhibit, what happened? There is no more stimulation on the vasomotor center. No more stimulation. No more stimulation of the cardiac acceleration center. This one is cardiac acceleration center. This one vasomotor center. There is no more stimulation of the adrenal gland and sympathetic system. So there is no function of vasomotor center. Reduced function of cardiac acceleration center. Reduced function of adrenal gland. What is your normal cardiac accelerating function? Normal cardiac accelerating center function. Increasing heart rate and increasing contractility. Those are the main function of cardiac accelerating center. It increases the heart rate. Once your cardiac accelerating center is stimulated, they increase the heart rate, they increase the contractility of your heart. Not only that, they increase the conduction velocity of the heart. Conducting velocity. They increase the abnormal conduction like ectopic beat. Abnormal conduction. Not only that, it increase the relaxation time of the heart. Not the time, relaxation is speed. It increase the relaxation speed. It increase the contraction speed and contraction power. It increase the relaxation speed. It rapidly relax. So called lucitropic effect. What happens your vasomotor center activate? They going to constrict your vessels. Once your vasomotor center activate, they going to constrict your vessels. Then they can increase your blood pressure. What happens your adrenal gland stimulate? Adrenal gland contain outer cortex and inner medulla. Inner medulla going to secrete adrenaline and noradrenaline. These noradrenaline and adrenaline can cause vasoconstriction, increase heart rate, increase contractility. Can be done by stimulation of the adrenaline gland. Now what happened in my previous example? I transfused 2 liters of normal saline. Now blood pressure 160 by 110. Aortic arch stretch more. Carotid sinus stretch more. They send impulse to the nucleus of tractus solitarius. They are going to secrete inhibitory neurotransmitters unfortunately. Because of that, no more stimulation on the nucleus of tractus solitarius. Therefore, no stimulation on the vasomotor center. So, no vasoconstriction now. Vessels start to dilate. Vessels start to dilate. When coming to cardiac accelerating center, no more stimulation on the cardiac accelerating center. So, heart rate goes down, contractility goes down, conducting velocity goes down. There is no ectopic beat, no abnormal conduction, and relaxation also now become longer. Relaxation also now become longer. Previously rapidly relaxed, now it will take time. What happened? Adrenaline, there is no impulse to the adrenal gland as well. So no adrenaline and noradrenaline, no vasoconstriction, no high heart rate, no vasoconstriction. That is what happened when blood pressure rise. We will see what happened when blood pressure drop. Now blood pressure drop into 90 by 60. I cut my radial artery. Now lot of bleeding is there. Blood pressure gradually come to 90 by 60. We will see what happened. Now previous stretch 120 by 80. Here now blood pressure 90 by 60. Do you think previous stretch is there? No. Now stretch is much more less. Now stretch will be like this. What happened? Do you think this receptor going to stimulate? No. Do you think this carotid sinus receptor is going to stimulate? No. Do you think there will be impulse via vagus nerve? No. Do you think there will be impulse via dorsopharyngeal nerve? No. So do you think there is inhibition on nucleus of tractus solitarius? No. There is no inhibition. So nucleus of tractus solitarius now freely can act. Why? There is no inhibition from vagus and dorsopharyngeal nerve. They can freely act. They cause stimulate vasomotor center and vasoconstriction. They increase the activity of cardiac acceleration center, increase heart rate, increase contractility, increase conduction, ectopic beat as well, and increase the relaxation. Not only that, they stimulate the adrenal gland, increase vasoconstriction, increase heart rate, and increase contractility as well. Not only heart rate, contractility as well. That is what happened when blood pressure drop. That is what happened when blood pressure up. Now we will move into the MCQ. It says carotid sinus have stretch receptors in their wall. Answer is correct. Not only carotid sinus, aortic arch also contain stretch receptors in their wall. Carotid sinus give afferent via glossopharyngeal nerve. Yes, this one is glossopharyngeal nerve, 9th cranial nerve. This one is 10th cranial nerve, vagus nerve. Carotid sinus afferent via fibers via glossopharyngeal nerve. Answer is correct. Stimulate the respiratory center. Did you see? Are there any respiratory stimulation? No. Answer is wrong. Contain chemoreceptor. No, those are mechanoreceptor, type of mechanic receptors. When you stretch, sodium channel open. So it does not contain chemoreceptors. Where are your chemoreceptors situated? Carotid body and aortic body. There is a small body in the carotid arch and the aortic arch and carotid sinus. Outside the wall, those are the chemoreceptors responsible for your pH regulation. pH means power of hydrogen ion regulation, carbon dioxide and H plus regulation. The involvement factor is chemoreceptor. But in this example, they say carotid sinus contain chemoreceptor. Answer is wrong. If they say carotid body contain chemoreceptor, then the answer will be correct. This one is called carotid body. This one is called aortic body. This one is called carotid sinus. This one is called aortic sinus. In that, the same scenario, this one is wrong. Next one, the carotid sinus stimulate the vasomotor center. The carotid sinus stimulate the vasomotor center. When the carotid sinus impulse reduce, what happen? No more inhibition of nucleus of tractus solitarius. Therefore, it will increase the activity of vasomotor center. Answer is correct. But it happens when the carotid sinus impulse reduce. The correct answer will be the carotid sinus impulse reduce will cause stimulation of the respiratory vasomotor center. Thank you very much. And sequence over.